Hello everyone and welcome to McLean 360. In this video, I want to solve a question with you to illustrate the concept of a simply supported beam, and you have been given the slope. Let's try to solve the question together. This beam is 4 meter long. It's a simply supported beam, and then the beam is supported at the ends, right? And it says that the beam is carrying a load W at the center. So we can imagine this beam as a simply supported beam here, which is having these reactions at the ends, and then there is a load at the center, W. Now the length from the question, the length of the beam was what? L is 4,000 millimeters, or in other words, 4 meters. And then we are told that if the slope, so dy dx, if the slope at the end, in fact, the maximum slope occur at the end. So if you say the slope at the end, then it means the maximum slope should not exceed. So that means should be at least equal to 1 degree. We have to find the deflection. So we've been given the slope, and then we've been asked to find the deflection. So this question is very simple and straightforward. But the first thing that we have to do is to look at the deflection, the slope. What is the formula for the slope? The formula for the slope, or the maximum slope, occurs at the free ends. Okay, so it's going to be like this. The deflection will take a form like this. Okay, and the slope, the maximum slope will occur here, and the slope at the center will be 0. And that is where the maximum deflection will also occur, at the center. Okay, so y max. All right, so let's the formula is actually WL squared over 16 EI. So let's convert. The actual unit for the slope is in radians. So we know that 180 degrees is pi. Therefore, 1 degree will be less. So if less, more divide. 1 over 180 multiplied by pi. And that will give us the actual angle for the, so pi over 180. What is it? So 0.0175. 0.0175, and that is in radians. Okay. Now we were given the length, isn't it? The length was 4,000 millimeters. All right, let's try and do something here. Let's say that the formula for the slope is this. Okay, I want to do something. And then what is the formula for the deflection? The maximum deflection, the formula is minus WL cube over 48 EI. Okay. Let's say you have been given something like this. Now, let's look at this. I want us to do something. Let's divide equation 1 and then equation 2 and see something. Let's try and divide equation 1 and equation 2. So let's say this is equation 1 and let's say this is equation 2. So if I try and divide this equation by this equation, 2 divided by 1, we will get dy dx maximum, all divided by y max, okay, should be equal to minus WL squared over 16 EI, all divided by, 2 over 1 rather. Yeah, it's correct. This one is supposed to be L cube over 48 EI, and then the one that is at the down one will be the oh no, please let me do it again. It's actually 2 over 1, so it's going to be y max divided by dy dx maximum, and then should be equal to minus WL cube over 48 EI Then I divide the whole of this by what? Minus WL square over 16 EI. All right. So we've got this, all right. But then what were we told? We were told that the slope is 0.0175. Okay. Should be equal to, now if we are dividing, then it means we can actually multiply and then inverse, turn it upside down and multiply. So it's going to be 16 EI divided by WL squared. If we do that, W will cancel W, EI will cancel EI, and 16 will go into 48, 3, right? So in fact, we are going to get, in fact, L square is also going to cancel, and then we are going to get only, so the minus sign will also cancel. So we are going to get L divided by what? 3. If you are not sure that 16 and 48, let me do it so that you'll be happy. So 16 divided by 48 is 1/3. All right. So now everybody is happy. All right. So now, okay. So now we have this. Let's solve for the deflection. Okay. Let's solve for the deflection. So from here, we can say that the deflection is L/3, 0.0175. And what is L? The length was given in the problem as what? 4,000 millimeters. So it's going to be 4,000 divided by 3 multiplied by 0.175. So that our Y max, which is the slope that we need, the deflection that we need, will be 4,000 divided by 3 multiplied by 0.0175. So 0.0175. And that's 23.3333. So maybe at least 2 is okay. So this is the deflection that we want. So this problem has been solved. Thank you very much for watching.